Here is one of the simplest biochar retort that I have used. This is a 200 liter drum, that is a steel drum, which is used. I have cut the lid into half and made hinges for that, so that I can close it also. And inside I filled with the loose biomass and then close the lid by shutting it down. It is lit from the bottom, so I placed a few bricks here for putting on this drum, and below which I used about 35% of the biomass to heat it. Here holes are not seen, but at the bottom I have made a few holes, very small holes, so that fire doesn't get into, but the emissions from inside would come out and they would get refied here, so that these pyro gases generated in the process need to be burnt again, so that it adds to the efficiency of using the biomass at the bottom. So we could see the intense fire that is happening below after burning for about half an hour, and it cooled down. After cooling, we could see the biochar formed here. Even the thinnest of the sticks are converted into biochar, and this is one method for converting loose biomass into biochar. This is one of the simplest methods, but the cost of that steel drum is something a burden for many people, because burning many times, as it is a iron made material, it would also rust for a period, and it will have holes and its life will go. So these are the choices. So I have different options and methods of teaching how to make biochar at the farm level, and this is also another method to do it. This whole thing I have done at Geo Research Center, where I have experimented, and about 7 different types of retorts or kilns or even pit methods I have designed there and tested them. That is way back from 2010, 11, 12. Had been doing a lot of experiments here. For biochar production, there are various means. I was working on this designing stoves. About 50 stoves I have designed. I have my own museum on stoves. From all the stoves, the byproduct is biochar. The quantity can vary even from the traditional cook stoves also. If one wants to retrieve this biochar at the end of cooking, they can retrieve. So it varies somewhere from 5% to up to 20% also one can retrieve this biochar from this cook stove by quenching or putting the sticks within the soil. There are various methods. I was working on a slightly higher end cook stoves. They are like a kind of gasifier stoves or wood gas stoves, what I call in general. So Make series is one series where I used this metal to produce these stoves. So Make CM2 is made from the used tin cans, and this is one of the simplest designs, but having these higher efficiencies of combustion and controlled air, I am getting good yield of biochar up to 20% and above. That is after using the heat for cooking. So that is the advantage in this particular stove. I designed it in 2008. So you could see the design here. There is a tray here down below. This is for controlling the primary air. So once it is lit, then I can shut it down, this whole thing. So there is very little air, that excess air goes from below, and these are the secondary air holes, and also I given one centrally located this pipe which is having these perforations, we can see. So this also gets heated, and the preheated air comes from here. So complete combustion happens for the biomass. Here we can see the details. This view is from top of the stove. I would put the wood shavings or any loose biomass, fill it, and then I would light at the top. So slowly it goes down. This is a TLUD stove, top lit updraft cook stove. So we know in all TLUD stoves the yield of biochar is considerable. Once it is lit, you can see the flame. It slowly goes down, burning the biomass. We can see the performance of this pipe also. We can see the fire here. So because there is some air that is coming out, the pyro gases get mixed with this air and then they combust. So there is no smoke in the stove. So I used 2 frames here. So in this particular stove regularly I use water, another tin can at the top with water. This water used for taking bath and other uses. One could see the complete combustion happening within this stove. Initially the primary air is open, then later it is closed, so that the biochar that is formed in this cook stove doesn't get combusted. At the end we can see the beautifully formed this biochar here. These are the design components here. So primary air from here, so there is a shutter to control the primary air, and secondary air holes are here, and also a centrally located shaft is there here, and there is a grate that is again perforated mesh, above which we put the biomass, that is loose biomass. Any loose biomass we fill it, and it is lit at the top and slowly it goes down. So this is TLUD cook stove. We can read the details here posted. Make CM2, it's a natural draft wood gas stove. Means here we don't use the forced air or fans or batteries or electric power. And it is a very low cost stove for heating and generating charcoal, that is biochar. It can also be described as a mini charcoal making metal kiln. Instead of incinerating biomass generated from home gardens or any other dry combustible material generated as household waste, usually throwing into the garbage bin, can be used here. The leaf litter, dry twigs or sticks, chips of wood, wood shavings, etc. are very much suitable. Again I am explaining the steps here. Put the biomass into the combustion chamber, lit the biomass from top, use the heat for heating water, cooking, etc. At the end, shed the primary air by closing the shutter that is located at the bottom. Cover the stove with a lid. Let it cool for some time. Turn the stove sideways for unloading the charcoal produced. Then sprinkle water for retrieving the charcoal, that is quenching. So this is a faster procedure for retrieving the biochar. Thank you.